guys, you're welcome to this channel. This is Bug Bounty and Android Application Security, the part 2 of the series. In the part 1, I talked about the need for Android application security and what you need to set up your environment. If you've not seen that video, I'll leave a link in the description panel where it will take you to the part 1 to see the video. Don't worry, we're going to wait for you. Just pause this video and come back to this video. If you are new to this channel, you can click the subscribe button to get subscribed to this channel, and also you can hit the like button if you like this video, and if you don't like the video, you know what to do, and also hit the notification bell to get notified on my future videos. And also I would like you to leave a comment in the comment section and tell me what you feel. So in this video, we're going to be going deep dive in Android application security. So what we're going to be learning in this video is Android architecture. We're going to learn how the Android operating system is built. And also, we're going to do an overview of Android version history. Thirdly, we're going to understand the Android application framework. Then we're going to go into Android reversing engineering toolset. We're going to list some of the toolsets you need for your Android application security. Then we're going to talk about the Android APK components. Then finally, we're going to do a demo. So to go deep dive, let's start with Android version history. So Android began releasing their versions in 2008. And if you can see in the list here, we have about we have more than 10 Android version that has been released since 2008. With the current Android version, which is 11 to be decided, the date has not been decided yet. Currently, what I'm using on my mobile device is Android 10. So this is important because when doing your Android reverse engineering, you might encounter some errors or some difficulties. So you need to understand where those errors are coming from if you're using the updated SDK version or you're using an outdated SDK version. So let's talk about Android architecture. So Android architecture has 5 components that is made up of. So in the first layer, we get to see the Linux kernel. So the Linux kernel is the bottom and most important layer of Android architecture. And it is the core part of Android architecture which provides features such as security, process management, memory management, device management, and multitasking. It is also responsible for a level of abstraction between device and hardware, and also upper layer of Android architecture. It consists of device layers and device drivers like camera, flash, display, keypad, Wi-Fi, and etc. Now the second layer has 2 sub-components. We have the libraries and also the Android runtime. Okay, for the libraries, Android component is built using native codes and require native libraries, which are written in C or C++, and most of the libraries are open source libraries. Also, this layer handles data that is specific to the hardware. Some of the native libraries include Surface Management, Media Framework, and SQLite, and so many others. While the Android runtime comprises of DVM. So DVM is a short form for Dalvik Virtual Machine, just like you can see in Java Virtual Machine, which is JVM. Android uses DVM to optimize battery life, memory, and performance. The bytecode generated by Java compiler has to be converted to .dex file by DVM, as it has its own bytecode. Also, multiple class files are created as one .dex file and compresses to .jar file, which is .jar file. Now, this is important because when we are doing our reverse engineering, after decompiling our application, what we'll get is docx file. And afterwards, we need to convert this docx file, which is a chunk of bytecode, to a human readable format. So in the third layer, we have the application framework. The application framework um, is built on top of the native library layer, which provide us with application programming interface and higher level services. Also, the features of this Android operating system are available to us through APIs written in the form of Java classes. Developers use these high level services to build application. It also consists of Android hardware abstract layer, which is HAL, and allows the Android application framework to communicate with the hardware specific device driver. It acts as an interface for hardware vendors to implement on the device. So on the application framework, we have Activity Manager, Windows Manager, Content Provider, View System, Package Manager, Telephone Manager, and the rest. So this is important because after the compiling our application, what we are going to be looking at is we are going to be looking at this different application framework. Most of them are activity managers, and it extends to content provider and other services. The applications sit on the application framework. It is the topmost layer in Android architecture. This um, topmost layer of Android architecture consists of native Android applications and third-party installed applications. So the native Android application includes the when you click on your contacts application, or when you click on the device browser, or when you click on the phone to make a call, or when you click on the camera. So this one that is listed on the application layer, they are native to the application, native to the phone. However, there are other installed applications you can also find on this layer, which is referred to as the third-party application that is on this application layer. So with this, let's quickly go into application framework services. Let's understand what this application framework services is. So we have about 5 components of these framework services. This is very important because most of the things we are going to be doing, we are going to be looking for how this application speaks to some of these services and how we can actually exploit them. So we have the activity manager, which in this class uses testing and debugging method. We have content providers. Content provider, it provides data from the application to other layers. Now the resource manager is provide access to non-code resources. We have notification manager. The users get notification about all the actions happening in the background. Then the final component is the view system. It acts as the base class for widgets and is responsible for event handling. So with this, let's quickly talk about some of the tool sets we're going to need in our Android reverse engineering. So these tool sets, we are going to use them in carrying out our Android reverse engineering. Now let me quickly brush down in what these tool sets, um, what we're going to need them for. Now the zip package is a package we use in unzipping a file that has been compressed, such as an Android APK file. The APK tool is what we're going to need this APK tool to decompile an Android APK, APK, and we can also use this APK tool to build a decompiled APK. The dex to jar is a tool that we're going to need to convert the .dex bytecode from the unreadable format to the human readable format of Java classes. Now, SQLite 3 is a tool set we are going to need to create a database and table and different tables, and also we use this SQLite to query tables that are stored in the local storage of the device. ADB2 is Android debug tool that is used to get or have a remote share connection to the device we'll be working with, and with that we can carry out many other functions after we have established connection. Now, JADEX GUI is a graphic user interface tool that we're going to need in reading .java files, and we can also use that to drill down to different subfolders of our .java files. Now, PIP is a Python tool that we're going to need in carrying out, in executing some of the tool sets that is written in Python, because most tool sets in Linux environments, they are written in Python. So Modbsf is mobile security framework. So this is a very powerful security framework that has almost everything we're going to be doing on our environment. So what this mobile security framework does is it is built and designed in a way to decompile an APK file, run a static analysis on it, and also give you a comprehensive report. You can also use this Modbsf to do your dynamic analysis. So Frida is also an instrumentation toolset that is used to carry out dynamic analysis. Why Droza is a very powerful tool that is used to discover vulnerabilities and carry out exploitation when we've done a remote connection to the device. So there are other tool sets, but let's stick to this particular one so that we don't get overwhelmed. Now, the anatomy of an Android APK file is what we're going to look at now. So when we've decompiled an Android APK file, by the left, that is what you're going to get. The listed folders there have subfolders. So let's quickly look at what this anatomy of Android APK file looks like. So first of all, the most important file after decompiling an APK file is the Android manifest, which has the extension .xml. Now, this is a summary of what or how the Android manifest file looks like. But when you are decompiling a real application, a live application, you're going to get more than 2,000 lines of code on this .xml file. It has several other tags like intent providers, service filters, and other tags. This is also a very important folder in the Android anatomy, which is assets. So asset is a folder where you get to see some of the resources that the application is supposed to function with. So among others, we have the WAV files. We also have some of the files. If you look to the left part of the screen, you get to see some files like CR, which are certificates. We have so many files that you can see on the left part of the asset folder. There are so many of them, and they are very important. We get to know what this asset has in stock. So the next folder we're going to be looking at is the Rex The rex is a short form for resources or resource folder. So all the resources like the activities, XML files, images, layout, drawable, colors, menu, map, raw animation, values, XML, and custom styles are stored here. It's a very long list of folders that you can find under the resource folder. So because this resource folder can go as deep as giving you some subfolders in each of these folders in a live target, in a live application. So the next folder we're going to be looking at is the classes.dex file. Now this classes.dex file contains the Dalvik, which is the virtual machine runtime and Android application. So is a chunk of bytecode that is not human readable. So we are going to convert the docdex file to .jar file so that we can be able to read them in a human format. So in this .dex file, this is where we are going to see all the source code, how the application works. This is the juicy part of the application after the manifest file and also the resource file. Now we also have the library folder. So in this library folder, we get to see all the file extension that the application is using, not just native, also third-party libraries. Now, these are the resource link to downloading and installing those two sets I earlier mentioned. I'm going to leave the link in the description panel so that you get to follow on the instruction on how to get it up working on your environment. So the last file we're going to be looking at is the meta inf folder. So the meta inf folder has all the certificate files we have and the manifest.mf files, the rs file, everything that has to do with certificate file, all will be found in the meta-inf file. So with this, I hope you understand the anatomy of Android application and you're ready to see some demo. Okay, come with me while we do some demo in decompiling Android application file. So before I forget, if you don't like this video, you know what to do. But if you like this video, hit the like button. If you are new to this channel, click the subscribe button to get subscribed to this channel, and also hit the notification bar, hit the notification bell so that you get notified in my future videos. So guys, this is our VMware workstation, and on it we have Kali Linux operating system running on it. So as I earlier told you, if you're using a Santoku device, Santoku operating system, those two sets that I mentioned are pre-installed. However, you need to update those two sets. But if you're working with Kali Linux, some of those two sets you need to install them, and you still need to run an update on the already installed application. So I have all those two sets installed, but I'm still going to show you how to go about installing or updating those two sets. So right here, if you click on this icon, this dragon icon, you get to see a drop down where you see all the applications on this operating system. So if you want to know if you have those two sets, for example, let's look for APK2 and know if we already have it pre-installed on our Kali Linux. So we just need to type APK2, and here it is. We have APK2 on our Kali Linux. So APK2 is not a graphic user interface, is a command line tool. So you're going to learn how to use a command line in working with APK2. So when you click on this, you see um, how to use the APK2. So we have different way to use it. But let me quickly show you how to install the APK2 if you don't have it installed on your machine. So all you need to do is to type this command sudo. Okay, let me clear my screen. So all you need to do is to type this command. Okay, sudo apt-get install apk2. So it's going to ask me for password. I type in my password and I click enter. Then it's going to say I should accept the terms and conditions by typing Y, which I typed, and it's going to download and install the APK2 on my machine. So because it's already there, it's going to overwrite the existing package. So that is APK2. So if you want to install the zip, oh my god. So let's install the zip tool. So first of all, let me clear my screen. So all I need to type is um, sudo apt install zip and unzip. So that is done. So we have it installed zip tool. So let me clear my screen again. So let's do um, SQLite 3. So type sudo apt get install SQL Lite SQLite 3, and you ask me to accept. Type Y, accept it. Then it's going to install SQLite. All right, that's fine. So let me clear my screen. So let's do Python. Let's install our Python package. So I'm gonna do apt install Python 3 dash pip. Oh, sorry, apt-get. All right, I think I missed something. Sudo. All right, that's fine. Sudo y. So sudo apt-get install Python 3. So that will install my Python 3 package. So that's that. So let's do adb install. So we have, let me clear my screen. So um, sudo apt-get install adb. Oh, sorry, I didn't type it well. Uh, sudo apt-get install. Oh, okay. I didn't spell the install well. All right, that's fine. All right, that's it. Sudo apt-get install adb installed. So we have pretty much all that we need, and yeah, pretty much all that we need. Then all right. So let's take it step by step. So um, we're not going to install MobSF, Frida, and Droza on this episode. So in the next episode, we're going to work with MobSF, Frida, and Droza. So let me quickly show you how to work with these tools. Let's take, for example, we have um, our device. Let me quickly launch our device. So we have our device, our virtual device here. Let me take me with my face because, all right, this is our virtual device. And we need to know the IP address of our virtual device. If you look, if you look here, you get to see the IP address you can use. This is the IP address, or you can use a different IP address. It will still connect to the same device by dragging this panel down, and you get to click on Wi-Fi and click on the Android Wi-Fi, then advanced, then you get to see another IP address we can use to connect to this device. So if you use this one, it will still connect. If you use this one up here, it will still connect. So with that being said, let's do a remote connection to this device from our Kali Linux. So to connect to this device, all you need to do is to type adb connect. You now type the IP address of the, what was our IP address again? Okay, let's use this one. 192.168.154.103. 192.168.154.103. .1, sorry, there's a comma, 103. Okay, so it has established connection successfully. So we have successfully connected to this device remotely from our Kali Linux. So we can get to do a whole lot of things by typing adb help to know how to use the adb command. So we have a list of different ways you can um, work with the adb command. So there's a global option. All right. So there is a version of the adb we are using, and it's installed in this path. So we have global option. We can do adb a to list all network interface. We can do, adb-d to use the USB device. We have several other commands we can use to do. Okay, let's do adb shell. So we have remote shell to this device. So we can list, we can do a list by typing lx. So this is the root directory of our device. So we can navigate to this data directory by typing cd see the data, and we're in data directory. We can list all that is on data directory, and you can see we have other um, directory under the data, and you can see we have cache, we have the local directory, we have the user directory, we have the system directory, we have juicy, we have media, we have app private, app library. So this app data is where our local storage is, so we can cd to it, we can do cd data, and we're in data directory list all. So under this you get to see all the application that are installed on this virtual device, on this emulator. So we have them, you can see them. This is a camera application, this is a native application, calendar, we have calculator, we have Bluetooth, we have all of them listed, all the application listed, both local and what we've installed on the application. So this is something that is running this settings application. We have phone to make calls, we have a pack processor, we have so many of them listed here. So this is what we're going to be doing when we have our application running on this device. So whatever application that is running will be listed here, and we can get to play with the application and know how the application behaves, and store data on the device. So that being said, I hope you enjoyed this video. If you like this video, please give it a thumb up by clicking the like button. But if you don't like this video, you know what to do. And also, if you are new to this channel, click the subscribe button to get subscribed to this channel, and also hit the notification bell to get notified when I upload new videos. So leave a comment in the comment section below and tell me what you feel about this, and I'll see you in the next episode. Thank you very much. Meet you there. Bye bye.